So we have lots of different challenges. So somehow we have to update our, like the early times that the activities that we are doing is not same, or the way that we are doing these activities are not the same. So somehow we have to modify our processes and quality assurance activities, not the process, not the way itself, but the things and the scope that we are doing are different. So we will investigate what kind of changes or updates we have embraced in our activities, and maybe what we can do furthermore in the last part of this presentation. So these challenges look a little bit like mission impossible. So there are lots of different difficulties. So how can we manage this? But of course, these are the things that trigger us to perform some updates and improvements. And in this way, we improve all the way, and we continuously maintain our processes and activities. So a little bit overviewing on the improvement of the quality assurance activities. This was the report reported in the World Quality Day in 2019. So we can see that it started with simple inspection activities, and then little by little with lots of different improvements. Nowadays, of course, there are lots of different certificates and lots of different ways to do the quality assurance activities with embracing Agile or IoT and AI contexts. And we can do lots of different quality assurance activities in lots of different domains. Thanks to these processes, we can embrace any of these approach, and we can improve our processes. And a little bit more focusing on the testing itself. First of all, we start with manual testing in Waterfall projects. And then again, as I told in the beginning, we start using some automation tools, but not the frameworks that we are developing, but simple basic tools, at least, which gives us chance to do some little scripting. And then we start doing some more complex automation in Agile projects. And Agile project, as you know, it is more open for changes. We can collect some feedback from the customers or end users, and if they request any change or update, then we are still very open for this. All the change requests and updates are welcome, and we try to adapt these kind of changes in our Agile approaches. And finally, rather than having big releases, we are doing the continuous activities, continuous integration and testing activities. And in this way, we are doing the DevOps approach. We merge together development and the operation systems, and we try to pull the end users close to the product or the development teams. And finally, maybe in the future, we will see more AI in our test activities. We already start to see them. There are lots of different products embracing AI in testing activities in all stages, even starting from the defining test cases. And then sometimes we see that it is used to maintain the test cases. There are some self-healing tools, and even developing the test code. I will show a few of them. We can use AI in lots of different stages of the testing life cycle. But first of all, let's start from what we have done from yesterday to today, which means from early stages, from the previous activities, how we changed our activities. The first replacement was the replacement of manual testing with automated testing. So automated testing is great. It gives lots of different chances to us, like some activities we cannot do with only manual testing. Like if I ask you to send lots of different concurrent requests to servers to perform a load testing, of course we cannot combine or we cannot collect a lot of people to do this in the meantime. It is not feasible. It is not possible. But with automated testing, we can do this. And not only this, but the continuous testing, like the executions, a lot of times, if we are supposed to do the executions in a repeated manner, in lots of different stages, then it is not possible to do this manually. But if we implement this then we will have the chance to execute in an automated manner. Maybe we can schedule our jobs, or maybe we can merge our jobs into the commits. And then whenever some change is supposed to be merged in the main branch, then the tests are triggered and they are executed to check the results. And in this way, we can ensure that the changes do not break anything. It is great. It has lots of different advantages. But on the other hand, it has some difficulties as well. For example, if the tests are not reliable, which means if I cannot rely on the test results, then I have to analyze, and I will require a lot of extra maintenance and analysis efforts. For example, if the test case do not report any failure, when there is a bug or any issue on the product, it means I have a silent horror case. Because there is a bug or there's a vulnerability I have to get rid of, but my test case do not warn me. It doesn't report any failure. So that will be reported in the later stages because I'm not capable of catching that on time, but they will be reported from the production environment. Maybe they will be reported by the customers. So of course, the intention is finding the bugs or the vulnerabilities in the early stages. But if my test case do not help me to do that, then maybe it means I'm not getting advantage of the test automation. On the other hand, if test cases do report some failures, when the features are working as expected, the features working as along with the requirements as it is expected to work, but somehow my test case fails. So it reports a failure. And in this case, it is not a real bug, but somehow I'm being warned, I'm being notified by the test automation framework. It says that there are some failing test cases. So I have to analyze them if they are real bugs or false alarms. So in this case, the false alarm is the cause resulting in some extra maintenance effort. So test reliability and test robustness is very important. But why can I have some test reliability issues? Because I may have some test smells in my test automation framework. There are lots of different test smell types, which you can find in the literature. If you do a survey, you will find lots of, maybe hundreds of different test smell types. As we know, the most common one is the flaky test, which sometimes passing and sometimes failing. But other than that, there are lots of different types, like maybe some of them are fragile. If we just change the test inputs, they will start failing. Or if we execute some of them in the same suite, then maybe some of the test cases will start failing, which means we have some maybe dependency issues. So there may be lots of different test smells. So we should get rid of all these test smells and we should improve the reliability of the test cases. So the advantage of the test automation is on the one hand, but on the other hand, we should continuously maintain the test automation. And of course, the way to improve the quality and the reliability of the test automation framework is maintaining the test framework and trying to improve the code quality. So if we have strong quality gates, maybe we can embrace the static code analysis tools, or maybe we can perform peer reviews. But in any ways, we can check the code quality in lots of different aspects. From the functional point of view, if the steps being implemented are matching with the test cases or test definitions, or if we have the correct assertions, if we are checking for the correct expected results, expected behaviors. Or other than that, if apart from the functionality, if the code is understandable, if someone new will join and try to understand this test code, is it understandable for anyone? Is it clear? Is it maintainable? Is it atomic enough? Because sometimes we are implementing too complex and complicated test code. So, and on the other hand, of course, we can introduce some other classes or methods to simplify our test case, test spec file. But on the other hand, introducing lots of different abstract layers may be more complex. So we should maintain the balance between the understandability and the maintainability, and we should improve the code quality as much as possible. And eventually we can improve the test reliability in this way. And the second replacement, other than the manual testing to automated testing, was, of course, the introduction of the agile practices. Nowadays, we are mostly doing the agile, maybe Scrum, maybe Kanban, but waterfall practices is not there anymore as a important part of our daily life. So, of course, again, it has lots of different advantages. For example, we can we can quickly embrace the changes or updates. So it is we don't have to wait for too long, and we don't have to do too long planning sessions. We don't have to work on the hundreds of pages of requirement documentation. But on the other hand, of course, again, there are some other difficulties. For example, yeah, in Agile, the working product is more important than the comprehensive documentation, but it doesn't mean that we don't need any documentation at all. Sometimes the features are not clear. So sometimes we have to clarify the features with the product teams. We have to sit together with the product members or the development teams to understand how it is being implemented. We have to understand the details. And maybe everyone has a basic understanding about the main usage. But when you talk about the details, maybe the negative scenarios, you may have some different answers. So you have to clarify what should be the expected behavior. Sometimes you have to talk to the end users to understand their expectation. So in this way, the efficiency and the close working way is very important. If we do not build a close communication channel, then we may struggle and we may have some escape bugs. Because normally in agile practices, the quality assurance teams should start their preparations in the meantime, just after the design is completed. Because otherwise, if something is changed or updated in the product, then if the test cases are not updated accordingly, then maybe we will not cover the new expected behavior. And we will have some coverage issues. We will have some coverage gaps. So the close relation, the close communication, and the close communication channels are very important. If we are not notified after any planned change, then maybe our test cases will be broken. A lot of times I'm hearing some complaints like the test case is broken and they have to fix in all sprints. Because why? Because they changed the expected behavior. But it's very normal, right? If we talk to the customers or even if we try to update some new technologies, new trends, and we have to update our specifications, then it should be a normal part of the agile practices. But the only missing part here is after these changes or updates are planned, the QA teams or the QA members should be notified. This change is planned. So please already start your preparations. And in the release time, in the deployment time, the test should be already ready for execution. Because otherwise, we will notify that we will realize that the tests are broken and we will spend some time to fix it if we do not do our preparations in advance. And other than that, the sharing the tasks and doing the correct things at the correct time is very important. For example, there are lots of different layers and levels of tests, right? If we try to cover most of the cases in the system level rather than unit tests, then maybe we will struggle because we have very limited testing window. And if most of them are not already covered by unit tests, then we will have some difficulties to cover most of the system level testing. So we have to build a good testing strategy and a communication channel to achieve our agile goals. Otherwise, we will have a lot of difficulties. And finally, the continuous deployment and the continuous testing. Since we are always continuously integrating our commits and our changes into the working product, we have to ensure that these changes do not break anything. So we have to continuously execute our regression tests. So in this way, again, this gives a chance us to do the continuous integration. We don't have to wait for some release times. We can immediately merge our planned activities. But this time, the continuity, the robustness of the test cases is a matter now. Because if tests are flaky and it is not robust and it is not stable, then sometimes it will fail, sometimes it will pass. So I cannot rely on the test result. So this test case is failing or passing, which is the correct result. So somehow I should make my test cases reliable and stable. And to ensure the reliability and the stability of the test cases, of course, depending on doing a continuous monitoring. Because not only the last execution, but I have to keep an eye on a bunch of the test results. I should have a test history. So in this way, I can compare all the results on which execution it failed and on which execution it was passing. In this way, I can understand how reliable it is, how stable it is, and I can observe how frequently, how often it is failing. So continuous monitoring is very important in terms of the test reliability, but not only the test reliability, but also in other aspects. We can do lots of different continuous monitoring activities. For example, we can collect lots of different metrics from the production environment to understand how the quality aspects are served in our product. For example, how responsible our product is. For example, sometimes maybe the customers are seeing some not responding pages or very slow pages maybe. So we can collect lots of different metrics, key metrics, to perform the performance, to perform the other quality metrics from our product. And we can try to understand how the customers are satisfied with by using this product. And we can try to understand the root causes for the quality issues. For example, when the product is being slow, or maybe when it is being not responsive. If it is doing this behavior under certain circumstances, then we may try to understand what is the root cause for this condition. And then we can try to improve the quality. For example, if it is stemming from some load issues, load testing issues, or just the performance of the product, then maybe we can try to improve our infrastructure. Like maybe we can introduce some load balancers and some other modules to distribute the load into different instances. Or we can try to improve the performance in some other ways. Maybe we can do a code review to understand in which ways we are spending too much time on the backend services, or maybe in the front-end services. Sometimes the requests are waited in the queue, for example. Then we can try to implement some new ways to improve this processing time. So these are all the improvements that we have embraced in our activities. They all have some different advantages, but in the meantime, they all have some different difficulties, and we have to take into consideration lots of different aspects. So maybe what we can do furthermore is to embrace some AI or machine learning practices to do that even in a more smart way. So let's a little bit talk about what we can do with the help of AI in our testing activities. Actually, we can utilize AI in all the stages in software testing lifecycle, starting from the analysis of the requirements and defining some test cases, and then maybe implementing our test codes. We can even use it to implement the test code itself, but maybe we can do our code review thanks to AI algorithms. We can reduce the manual effort to do the code review, and we can already notify the coder to improve some aspects, even in the first place, before sending our code review. And finally, we can analyze the executions, and we can let AI algorithms to analyze the executions and try to find out some maybe not expected conditions. If some of the executions are different than the others, then the AI algorithm can detect this, and there's something wrong with this execution, and it can notify the tester. So please go ahead and check this execution, and if there is anything which is not in the expected pattern, then maybe please check. And if there is something to be fixed, then please do it. So these kind of things can be embraced, and in this way we can reduce the manual testing activities and efforts, and we can reduce the time needed to complete our activities as well. So let's start from the first one. The first stage, the first ring in the whole chain is the test case design. After we analyze the system under test, we understand the specifications, then we can try to cover them with test cases. So first of all, we design our step-by-step test definitions, and then we will execute these step-by-step test scenarios. But first of all, how can we design and describe some test steps to perform some test scenarios? Actually, when we look from the test, from the AI perspective, it is very similar to a testing activity performed by a manual human tester. What we do generally, first of all, if you ask me to test your system, my answer would be, okay, I will test, but first of all, let me understand how your system works. Please teach me. Please give me some documentation, or please give me the product itself. So I will start the exploratory testing. I will explore. I will send some maybe random request. I will play around on the front end. I will click the buttons. I will observe what is happening after each action. I will do a lot of actions. I will send a lot of requests, and I will observe the responses. Sometimes intentionally, I will send some wrong requests, and I will observe what is the behavior of the system. So in this way, I will understand the patterns in what ways, in which conditions, how the system is reacting. For example, for the unauthenticated request, maybe the system is responding with 400 responses, 401 or 403, or any unauthenticated response code. After I realized that, maybe in any other endpoint, if I send another request with a wrong token or without an authentication token, then I will expect the same response code, because with the other services in the system, or with the other endpoints in the system, that was the case. If I send a request without any token or with a wrong token, not authenticated token, I get some 400 response codes. So in this service, I expect the same, because that was my learning. So it works in a similar way for the AI algorithms. First of all, it learns. It observes lots of different samples we collect for training. And then in the testing stage, it sends the request, and it has already the expected label according to the past observations and learnings. And it observes the actual response by getting the response from the system. For example, I put an example here on the slide on the right-hand side. It is just a data which we can send on an API. For example, let's suppose we have a library API, and we can manage lots of different books. And we have some, in each entity, we have some different attributes, like you can read the ISBN number, or you can see the price of the publisher of each book. So maybe you can update some books by passing the book ID. You can maybe update the price, right? You can do some increase or decrease in the price. So you can add a new value, and you can send your requests. So after doing all these observations, and after we teach what should be the expected behavior, then the AI algorithm can inject some different values. For example, it already another thing that it can learn is not only the data values, but also the data types. For example, if it learns that ISBN number should be a value in a string format, then maybe it should put some values in a different format, like dashes in the wrong places, or for the price, maybe not double value, but maybe something with minus value, right? These all will be negative test cases. So the expected responses would be something like that, maybe bad response code, 400 response code, or something like that. These all can be performed by AI algorithms. So I think there's a question here. What is the difference between learning algorithm and the algorithm that the model uses? For building the AI algorithms, first of all, we need to perform the training, which we can call the learning algorithm. In this way, the model can learn the patterns. And then, of course, we can verify the performance of the model with the verification or the test stage. And then in the production, we can use this. So the outcome of the learning model will be used by the AI algorithm itself. So they are connected to each other. And after the observations are used by the AI algorithm as an input, then the upcoming samples should be either classified or should be decided by the AI algorithm for the relevant action item. So the next thing which we can do after the test definition is, of course, implementing the test code. So again, we can somehow get help from the AI algorithms. For example, even on the left-hand side, there's an example which is converting the natural language to the test code. We can just write some test steps, like first navigate to this URL, and then click this button, and then observe the response, or any other test step we can just introduce, just in the natural language, in English, in any other language, Japanese, Arabic, Turkish, whatever it is, we can write our test steps. And it is automatically converted to test code in any language, Python, Java, or whatever we are using. So it is very convenient. At least the template of our test code can be generated in this way. But other than that, of course, front-end automation, most of the testers are struggling with the reliability or the robustness of the front-end automation, right? So if the layout of the page is updated, then our locators are broken. Normally, in traditional way, we are using the XPath or the class path or the class names or the IDs, but most of the cases, we don't have the ID over there at all. So we are using paths or class names. But if they change it, then our test cases are broken because they cannot find the element on the page anymore. So what we can do is, maybe rather than using the traditional way, maybe we can use the visual locators. So even if they change the layout, then we can still locate our elements. For example, if I'm looking for the submit button, then I can say the AI algorithm that I'm looking for a button. For example, I'm looking for a radio button in circle form, and the label should be submit. And I can introduce even some further limitations, like it should be under the please enter your query text. Under this text, I'm looking for a button with the label submit. Under these constraints, the AI will try to localize by visual recognition. And if we already train the model with lots of different submit buttons, other samples, then it will easily find the button that I'm looking for. So even if the class path or the ID is not there anymore, then my test case will not be broken in this way. And after the implementation, the next thing that we are doing in the software testing lifecycle is the execution. So we can execute our test cases either in manual ways or the automated ways. But if we are doing the automation, then we can embrace some more AI practices. For example, if in each execution, if we let AI observe what are the execution dynamics, then it can find some, if there is any execution which is different than the normal pattern, then it can notify us to reduce the manual analysis efforts. For example, let's think about the execution duration, to give a concrete example. If, for example, the average execution duration for a set of tests is, let's say, 30 seconds, then the AI will observe the next execution will take maybe 35 seconds. The next will take maybe 28 seconds. So something around 30 seconds. But if it realized that one of the execution took not something around 30 seconds, but maybe 2 minutes, 3 minutes, So this way, it will notify me that the pattern, after I observe and after I learn that, normally the average execution duration should be something like 30 seconds. This was my learning from the past executions, but this time in this execution, it took 3 minutes. So maybe there is something wrong. Maybe one of the servers did not respond in time. So please go and check what went wrong in this way. So in this way, I do not have to go over all the executions one by one, but instead the relevant one was already sent to me by the AI algorithm. So I can go and check and find any possible or potential weaknesses or the bugs which may happen in the product. And finally, the maintenance. Of course, the automation, we are implementing our test cases, but of course, we are continuously maintaining. So one thing we are doing in the maintenance stage is, of course, reporting the bugs. So, but maintaining bug and managing bug is a kind of classification because we are doing the bug triage. So each time we are reporting the bug, and then we are deciding what should be the severity of the bug, or who should be the assignee, to whom should I assign this bug. So if I'm doing this triage in the wrong way, then I will lose some time. For example, if the bug is a critical one, the severity should be high. But if I label this with a low severity level, then maybe in the sprint planning, we will see that, okay, this is not too much severe, so let's postpone this. But normally it should have been high criticality. So I'm postponing the urgent fix into later stages or later sprints. So doing triage in the correct way is very important. So since this is a classification problem, is it either severity 1, severity 2, severity 3? Then we can use AI algorithms to classify, and it will be more accurate. Because as a human tester, when I'm raising a bug, I'm not checking all the other bugs. So maybe it will be inconsistent. For me, it is severity 2. But for another person in the project, maybe it is not severity 2, it is severity 4. But if we let AI to observe all the bugs, because this is something that the human cannot do. Like if we are talking about big data, if I ask you to observe all the bugs, read all the bugs, maybe 1,000 bugs in the project, which were already reported in a minute, then you cannot do it. But AI algorithms can simply do it. So this is the advantage of the AI algorithms that we can make use of. And we can, in this way, we can do the bug triage or the bug management in a more accurate and consistent way. Other than that, of course, we can do some code reviews as well. For example, if we teach the best practices, or on the other hand, the anti-patterns, like having some magic numbers in the code is not a best practice, right? It's an anti-pattern that we should avoid. In this way, if we teach this, then the model will, when we send the code for review, it will say that you taught me that having some magicals, having some embedded values inside the code is not a best practice, but here I'm seeing some magical numbers. So please remove this, or please introduce some smart variables to get rid of these magical numbers. Or if we can teach lots of different patterns and best practices to be checked in the code, and in this way we can do the code review. Still, we can do the peer review after this check, but of course it will already give some insights which can be fixed in the first place even before starting the peer reviews. So it will give a lot of advantage to remove or at least reduce the manual efforts or the time needed to complete our activities. So let's wrap up what we have discussed. So we improved our testing activities in lots of different ways. Considering the previous times and considering the activities that we were doing in our daily activities previously, we were doing mostly the manual testing activities, but nowadays we are doing the test automation with very smart test automation frameworks. Not only the test scripts, but even for our test automation frameworks, we do the API automation, we do the UI automation, we do lots of different testing activities, load testing, performance testing, chaos testing, and sometimes even the accessibility, usability. And we have test automation framework supporting lots of different executions in lots of different platforms. We are doing the compatibility testing. Sometimes we are just changing the browser and we are just changing the platform. In this way, we can test on desktop and mobile as well. So we can cover a huge scope with our test automation frameworks. And we are working in agile practices. We are embracing agile workflows. So in this way, very open for changes or updates. So customers can request any change request after the requirements are fixed. We don't accept any change. It is not the way anymore. So anytime we can collect some feedback and we can embrace these changes. And we don't have to wait for big release times. Our next release is 3 months later. No, it is not the way anymore. So every day we are doing a lot of continuous integrations and continuous deployments. So all these kind of transformations gave us a lot of advantages and benefits. But on the other hand, there are still lots of different challenges. And maybe what we can do furthermore to improve and get rid of or to cope with these challenges is we can embrace machine learning algorithms in our activities. It will not solve, as always this being discussed, even in this conference, there are a lot of discussions. Will the robots will replace us, the human testers? Maybe we will not replace 100%, but for sure it will reduce the manual testing activities or manual testing efforts, or at least the time to analyze the executions, analyze the test inputs, or analyze all the other aspects of the testing activities. So somehow, if we do a correct or accurate training, we can get some advantage from the machine learning activities as well. So this was all from me, including the transformations and the improvements which conclude in the evolution of software testing, and maybe what we can do in the future more using the AI in our daily activities. But thanks for listening, and if there are any questions, I will be more than glad to try to answer them. Thank you. But even if not, you can reach out to me anytime. I put some contact channels here. So please do not hesitate to reach out to me. And if you have any questions or any feedback, just feel free to connect to me.